Okay, this is going to be a recap of our acceleration lab that we did in class. Hello, cow, and hello, car. Good. So just to remind you what we did in class in the lab, we did two different parts of the lab. One of them, we measured acceleration versus a changing mass. And what we saw is that as the mass went up, the acceleration went down, and it gave us this kind of graph. And we were able to figure out with an equation that acceleration was proportional to 1 over mass. The second part of the lab, we measured acceleration and we changed the force, and we saw that it went like this. And we were able to reason that acceleration is directly proportional to the force. And when we combined these two together, we saw that acceleration is going to be equal to force divided by mass. This we also can change into force equals mass times acceleration. And then this one over here is going to be Newton's second law. That's Newton's second law, this one right here. I actually prefer to think about it in terms of acceleration as force divided by mass. So what can we do with that? Well, let's say that, should we use the cow? Let's use the cow. Well, let's use the car, since the car, we can imagine, maybe doesn't have very much friction. And let's say we apply a force to this car in this direction. And I'll just say it's an applied force, and let's say it's 500 newtons of applied force. And move the car out of the way. There's the car. And there's its wheels. So we'll look at the car from this angle, right? Let's say that I happen to know that the mass of the car was 100 kilograms, which would be a very, very light car. 100 kilograms is like 200 pounds. So what we can do with this equation up here is we could figure out what the acceleration of this car is going to be. So that's pretty easy. Acceleration is force divided by mass. So I just take my 500 newtons divided by my 100 kilograms. And that's 500 divided by 100. That's going to give me 5. And the units are going to work out to be meters per second, or meters per second squared. Sometimes that's what we write. So you can use this formula to figure out how quickly something's going to accelerate when you know what kind of force is acting on it. Now there's one other thing I need to add in here, and let's use the cow as an example. If I happen to have a force pulling this way, let's say an applied force of 300 newtons on the cow, and then let's say maybe there was a rope or something attached to the back of the cow. I'm going to turn this into a free body diagram. So let's say there's a rope attached to the cow, so maybe I have a tension force, and let's call that 200 newtons. Yeah, maybe once again we're looking at the cow from the side. And I'll make the mass of the cow 50 kilograms, which is very light for a cow. That's only 100 pounds or something, right? So what's missing from this equation up here is the fact that when we have multiple forces acting on it, we need to add up these forces and we need to add them up like vectors. So I think it probably wouldn't be too much of a surprise if I set up this equation and I wrote F over m. Wouldn't be too much of a surprise to see that if I took this 300 and this 200 and I needed to balance them out, then I would get 300 minus 200, and that would give me 100 newtons divided by 50 kilograms. That's going to give me 2 meters per second. So what's missing from this equation over here is we actually need to write F net inside of there. So I'm going to pop back up here, and I'm going to write F net, and I'm going to write F net. When we write F net, what we're talking about, maybe to go in a different color, F net means the sum of all the forces. That's what F net means. We need to add up all the forces that are acting on it. So there's a different way that we can write this. Writing sum in a math class, sometimes you can use this capital letter sigma, which means adding things up. So if I'm going to write the net force, then that's going to be the sum of the forces. Net just means the overall result after you've accounted for everything. So sum of the forces equals mass times acceleration is a little bit of a better way to write Newton's second law, or F net equals mass times acceleration is another way to write Newton's second law. And that just means in the example down here, we take into account we've got 300 one way and 200 the other way. Okay, that was just a quick little recap.